Welcome back to Chapter 3. Starting off here, we're going to talk about conversion factors for chemical formula. So chemical formulas contain within them inherent relationships between the numbers of atoms and molecules, or the moles of atoms and molecules, if we're talking about a larger sample. These relationships between the different atoms and the different elements inside of a molecule can be used to determine the amounts of constituent elements and molecules, such as percent composition. This is it's not really right to call it a property. It's more of a way of describing a sample that in certain situations is actually very useful. We won't use this all the time, but there are certain situations where percent composition is quite useful. So if, for example here, if we're thinking about calcium chloride, a sample of calcium chloride will always have one calcium atom for every 2 chlorine atoms. And that is by definition. If you don't have that ratio of 1 to 2, then you don't have calcium chloride, because that is calcium chloride. It's 1 calcium for every 2 chlorines. So because the number of atoms is always in that ratio, the masses are also going to be related to each other by a certain ratio. It's not going to be 1 to 2 because the atoms aren't the same size, but they will still be proportional to one another. There'll be a relationship between the mass of the calcium and the mass of the chlorine for any sample of calcium chloride, no matter how big or small. And this is what we call the mass percentage, or percent composition, which is just two of the same thing. It means the same thing. That's just 2 different ways of describing it. So what the mass percent, or percent composition is, it is the part that you're interested in, which could be any section of the molecule, divided by the mass of the whole molecule, so the mass of the part divided by the mass of the whole, times 100%. And that will give you the percent mass, or the percent composition. So for calcium chloride, as an example here, if we want to know what the the percent calcium is in this particular molecule, what we need to do is we need to find the mass of calcium and then divide that by the mass of calcium chloride. So if we look at the periodic table, calcium has a mass of 40.08, and I think I'll do this part up here. So 40.08 grams per mole. So that's just the one part we're interested in. Excuse me, because we're trying to find the mass percent of calcium. The whole molecule is calcium chloride, and so the whole molecule is going to be 40.8 plus 2 times the mass of chlorine, which if you look at the periodic table is 35.45. And that is also going to be grams per mole. Both of those things here are grams per mole. So the grams per mole actually cancel out, which is intentional. The grams per mole should go away because this is just a ratio. This is all we're looking at here. We're going to finish it by multiplying it by 100%. But if I go ahead and do the math here, grab my calculator real quick, 40.08 divided by 40.08 plus 2 times 35.45 times 100 gives me 36.11%. So the mass of any sample of calcium chloride, in that sample, 36.11% of that mass is due to the calcium. No matter what the size is, 36.11% of it is calcium. The other 63.89% would be chlorine. Since those are the only two things in the molecule, just whatever's left over, that would be the amount for the chlorine. So if, for example, we had exactly 100 grams of calcium chloride, we would have 36.11 grams of calcium in that sample. But we don't need to have those nice round numbers. We can do it with other numbers as well. So for example here, if you have 54 grams of calcium chloride, how many grams of calcium do you have? There's a couple slightly different ways that you can do this calculation. That it's just kind of two different ways of looking at it, but you're really doing the same math. One way to do it is to actually just use this equation, and I think we'll go ahead and stick with that. Like I said, there is a slightly different way of doing it, where the math is actually the same, it just looks different. But I think it'll be easier if we just go ahead and stick to the equation here. So if we do that, let's see here, erase that mark right there. So if we want to know how many grams of calcium we would have for this size, what we can do is we can just plug in the numbers that we know into this equation. And so I'm going to go ahead and write it off to the side here. I know I don't have much space, but I'm going to write it there. So the mass percent for calcium is this, 36.11%. We figured that out up here. So that's what we're going to put there for the mass percent. That is equal to the part, which is what we're looking for. And I'm going to run out of space there. Divided by the whole, which we're told our whole sample was 54 grams, times 100%. I know I'm going to, maybe, nope, couldn't fit it in there. So pretend like there's a percentage there. So this is an equation with one unknown, which is what we're trying to find. It's the mass of the one part that we're looking for, the calcium. And so if we do the math here, it's just some simple multiplication and division. So we're going to take 36.11 divided by 100, because that will get essentially moving this 100 over to this side, so that gets rid of that here. And then we're going to multiply both sides by 54. That will give us the part, which is the mass of the calcium, is 19 point, let's see, I only get 3 sig figs, so 19.5 grams. And if we kind of think about that answer, it should make sense. And it does make sense, because we have roughly a third of the mass is due to calcium, and 19.5 grams seems to me like it's roughly a third of 54. So that makes sense to me. Now remember, this only works, so if you were asked to find the grams of chlorine, you would have to insert the percent mass of chlorine here. So it's very important that this is the percent mass of the calcium. This is the part of the molecule that is made up of calcium, and then this is the whole molecule there. So you can find more examples like this in the book if you would like to practice with those. But I think we'll go ahead and call it there for this video. It's a really nice and short video, mainly just because I don't want to jump into solutions in the same video where we cover the percent composition. So we had a really long video last time, now we have a really short one, so kind of balance each other out there. In the next one we will get into solutions and talking about what those are and what they're made of. So I'll see you in the next video.